Welcome. We're diving deep today into a presentation from Basil's Knowledge Bunker themed Giving IT Back.
Yeah, their stuff's usually pretty insightful.
You gave us an overview titled Security in Azure.
Yeah, it's a big one for sure.
Yeah, you sent over a really detailed guide on this, sort of a masterclass.
Module 3, I think it was.
Yeah, Module 3, that's right. And it really digs into all the core security services that Azure offers and, best practices for using them.
Right.
So in this deep dive, we want to go beyond just, listing out the features.
Yeah.
We really want to understand how all these pieces fit together to create a really strong security framework.
Absolutely.
For protecting both applications and the data they use. So by the end of this, you should not only know what Azure offers, but also, be able to think about how to actually apply it all effectively.
Exactly. Yeah. It's one thing to have a list of features, but it's another thing to actually know how to use them.
Exactly. All right, let's jump right into it. So first up, we have slide 2, Azure Key Vault, secure storage for secrets. So when we talk about Azure Key Vault, I want you to picture this. Imagine your applications have a collection of really sensitive secrets.
Right.
Things like passwords to core systems or those database connection strings that allow different parts to talk to each other.
Yep.
Instead of scattering these, vital pieces of information across different config files, Azure Key Vault gives you a central place, a digital vault to keep them safe.
Right.
I kind of think of it like Fort Knox, but for your applications in the cloud.
I like that analogy. And inside this Fort Knox, you have different compartments for different types of secrets and keys.
Right.
So let's start with key management.
Go ahead.
This is where you manage the cryptographic keys themselves. The digital keys used to encrypt and decrypt your data.
Gotcha.
And one thing that's great is how flexible Azure is.
Okay.
It supports all kinds of keys and encryption algorithms, so you can choose the right one for the specific job.
Yeah.
Like having different kinds of keys for different locks.
That makes sense.
Now, if you have really, really important keys,
Right.
the ones protecting your most valuable data,
Uh-huh.
you can even store those in hardware security modules. We call them HSMs.
HSMs, okay.
Yeah, so it's like taking your most valuable jewels and locking them not just in a safe,
Right.
but in a separate, heavily fortified vault.
Okay, so it's not just keeping the keys secret. It's also about protecting the keys themselves with some serious hardware for the really sensitive stuff.
Exactly.
So we have key management. What else is in this vault?
Well, alongside key management, you have secret management.
Secret management, okay.
This is where you store those, everyday sensitive pieces of information that
Right.
your applications need to work.
Uh-huh.
Things like database passwords,
Right.
API keys for using other services,
Yeah.
connection strings, things like that.
Gotcha.
So instead of, maybe leaving those exposed in config files. Right.
Or even in your code itself.
Right.
You can keep them safe and sound in Key Vault.
So it's like, instead of hiding your spare key under the doormat,
Right.
you're putting it in that super secure safe deposit box.
Exactly, yeah.
Yeah.
Much less risky that way.
Definitely a safer approach for those important but potentially risky pieces of data.
Sure.
Now, I also see here that Key Vault handles certificate management. It does. I'll be honest, that always seemed kind of complicated to me.
Yeah, it can be.
How does that work within Key Vault?
Well, digital certificates are essential, right?
Yeah.
For verifying the identity of your websites, your services, and for enabling that secure encrypted communication.
Right.
So Key Vault,
Yeah.
since it can already manage keys and secrets,
Okay.
you can also manage the entire life cycle of these digital certificates,
Okay.
storing them securely,
Yeah.
and maybe even more important, automating their renewal.
So it's like a service that automatically renews your driver's license before it expires.
Okay.
So you don't have to worry about it.
That's convenient.
Yeah, it saves you a lot of hassle
Right.
and prevents those outages that can happen when a certificate suddenly expires.
I can see how that'd be a problem.
Happens more often than you'd think.
Really?
Oh, yeah.
Okay, so that automated renewal is a big plus, both for security and just for making life easier.
For sure.
Now, one thing the guide stresses is that Key Vault is just for these digital secrets,
Right.
not for managing user identities. Can you unpack that a little bit?
Absolutely. It's important to remember that Key Vault's job is to protect application secrets,
Okay.
not to verify who a person is or what they're allowed to do.
Right.
That's the role of Azure Active Directory.
Azure AD.
Yep.
Okay.
So think of Key Vault as the lockbox and Azure AD as the security guard at the door.
Okay, got it.
Azure AD checks your ID, and then Key Vault manages access to what's inside based on that verified ID.
That makes sense. Keeping those functions separate seems like a good design principle.
It is. It's all about security and layers.
So we have this super secure vault.
Right.
How do we control who can get in and access all the valuable stuff?
That's where role-based access control comes in.
RBAC?
Yeah, RBAC.
Oh.
With RBAC, you can be really specific about permissions. You decide exactly which users or groups or even applications can do what with the keys, secrets, and certificates that are stored there.
So it's about that principle of least privilege.
Exactly. Grant only the access that's absolutely needed.
Okay.
For example, you might allow an application to read a database password, but not to delete or change it.
Gotcha.
Just like different employees at a bank might have different levels of access to the vault.
That's a good way to think about it. Need to know access, but for our digital infrastructure.
Right.
All right, let's move on to slide 3.
Okay.
Authentication and authorization in Azure.
Okay.
We kind of touched on this with Key Vault, but
Yeah.
let's zoom out a bit and talk about access more broadly.
Sure.
So whenever anything tries to access a resource in Azure,
Okay.
whether it's a person, an application, a service,
Right.
trying to get at those secrets in Key Vault or data in a database, there are 2 basic steps: authentication and authorization.
Right.
So authentication is all about proving your identity,
Yeah.
showing that you are who you say you are.
Right.
And as we mentioned, in Azure, this often uses Azure AD.
That's right.
So it's kind of swiping your badge to get into a building.
Exactly.
The system checks your credentials, makes sure you're legit.
Right.
But just because you're authenticated doesn't mean you can do everything, right?
Not at all.
So that's where authorization comes in.
Right.
It determines what you're actually allowed to do once you're in.
Right.
And that's where those access policies and RBAC roles we talked about earlier become important.
Exactly. They define the scope of your permissions once you've proven who you are. Again, the principle here is least privilege. Give only the minimum access needed to do the job.
So it's like, yeah, you might swipe your badge to get into the building.
Right.
But your access card might only let you onto certain floors or into certain rooms.
Exactly. That's a great analogy.
So authentication is proving who you are, and authorization is about what you're allowed to do.
Precisely.
The guide also mentions app service authentication.
It does.
Does that just simplify things for web applications?
Yeah, app service authentication are sometimes called Easy Auth now.
Okay.
It's built into Azure App Service,
Uh-huh.
and it makes authenticating users for your web apps so much easier.
Right.
Instead of writing a bunch of code to handle sign in and sign out and all that stuff,
Right.
Azure handles it for you.
Nice.
It integrates with Azure AD, of course,
Okay.
but also with social media accounts and other identity providers.
So it's like having a security guard at the door of your web application who checks everyone's ID. Saves you the trouble of having to build and manage all that security yourself.
Exactly.
Nice. So it's a big time saver.
Yeah.
And helps make sure authentication is consistent across your web apps.
Yep.
Now, there's a pretty important warning in the guide here. Once applications retrieve secrets from Key Vault, they're not really protected by Key Vault anymore. Why is that such a big deal?
It's a big deal because once a secret is outside of that secure Key Vault environment, its security depends entirely on how the application handles it.
Okay.
Remember that Fort Knox analogy?
Yeah.
Once you take the gold out of the vault, it's up to you to keep it safe.
Makes sense.
Same idea here. If your application gets a database password from Key Vault,
Okay.
that password is now in the application's memory.
Right.
Maybe it gets logged somewhere. Maybe it gets sent somewhere else.
Yeah.
Key Vault did its job by storing it securely and controlling access.
Right.
But it can't control what happens to the secret once it's out. So developers need to be super careful and use secure coding practices.
Okay, so Key Vault secures secrets at rest and during retrieval.
Right.
But the application itself has to be designed with security in mind to handle them properly in use.
Absolutely.
All right, moving on to slide 4, cryptographic key protection options.
Okay.
So we talked about those HSMs earlier, but let's dig a little deeper into the choices for protecting the actual keys within Key Vault.
Okay. So you basically have 2 main options.
Okay.
Software protected keys and hardware protected keys.
Okay.
Software protected keys are managed by Azure itself using software-based cryptography.
Gotcha.
Like a strong digital lock on a file on your computer.
Okay.
Generally secure and works well for many situations.
Yeah.
This option is usually more affordable and easier to manage.
Right.
Good choice for apps that handle moderately sensitive data.
Okay, so software protection is a good baseline,
Right.
often simpler and easier on the budget.
Yep.
What about hardware-protected keys? What makes them different?
Well, they take security to a whole new level.
Okay.
These keys are stored and managed in those dedicated HSMs we talked about.
Right, the hardware security modules.
Yep. Imagine replacing that software lock with a physical, super secure safe designed specifically to hold and work with your keys. These HSMs have physical security to prevent tampering
Okay.
and often meet some pretty strict compliance certifications,
Okay.
like FIPS 142 Level 2,
Gotcha.
essential for highly sensitive data that needs to meet strict regulations.
So like if a compromise would be really bad news.
Exactly.
So the choice between software and hardware protection really comes down to
Yeah,
how sensitive the data is and what kind of compliance rules you need to follow.
right.
The more sensitive the data and the stricter the regulations,
Yeah,
the more likely you are to need the extra security of HSMs.
exactly.
Okay, let's switch gears a bit and talk about slide 5, managed identities for Azure resources.
Right.
This sounds like a smoother and more secure way for Azure services to talk to each other.
It is. Managed identities are really a game changer for simplifying security between Azure services.
Okay.
Traditionally, if one Azure service needed to access another,
Yeah.
like a web application needing data from a database or a storage account,
Right.
you'd often have to manage credentials,
Yep.
like
Sure.
connection strings, usernames, passwords.
Right.
But managed identities get rid of all that.
Nice.
Azure automatically gives each supported service its own identity in Azure AD.
Okay.
It's like instead of each service needing its own key or password to talk to the others, Azure just handles it all centrally.
Got it.
Much cleaner and less risk of accidentally exposing credentials in your code or config files.
So much better from a security standpoint.
Yeah.
So how do these managed identities actually allow services to communicate securely?
Okay, so once a service has a managed identity, it can use that to prove who it is to other Azure services. The process involves the service requesting an access token from Azure AD, which it then shows to the target service to authenticate.
Got it.
The great thing is, developers don't need to deal with any credentials directly.
Okay.
Azure takes care of all that authentication behind the scenes.
Sounds very streamlined. Now, you mentioned 2 types of managed identities, system-assigned and user-assigned. What's the difference?
Right. So a system-assigned identity is tied directly to a specific Azure service instance.
Okay.
When you enable it, Azure creates and manages that identity in your Azure AD tenant. If you delete the service, the identity goes away too, like a badge that's issued to that specific service and taken back when the service is decommissioned.
Makes sense.
A user-assigned identity is a bit different.
Okay.
It's created as a separate Azure resource, independent of any specific service.
Okay.
You can then associate one or more services with it.
Gotcha.
More flexible because the same identity can be used by multiple things.
Right. And the identity sticks around even if you delete or change the services using it.
So it's like a reusable badge.
Exactly. You can assign it to different services as needed.
Okay, that makes the distinction clear.
Good.
System assigned is tightly linked to a service.
Right.
User assigned is more flexible.
Exactly.
Now, there was also something about a token service mentioned in the guide. How does that fit into all this?
Right. So when a service with a managed identity needs to access another service, it doesn't just show its main ID to the target service directly. Instead, it talks to a special Azure AD token service and asks for a short-lived access token. This token acts like a temporary credential
Gotcha.
that the service can then show to the target service to authenticate.
So it's an extra layer of security and abstraction?
Exactly. Like the service getting a temporary pass
Okay.
before trying to access another resource
Gotcha.
instead of showing its main ID every
Oh, it's
time.
separate. And these tokens expire after a short time, which helps limit the damage if one is compromised.
That's good.
And the best part is that all this happens without developers needing to manage any sensitive credentials directly in their code.
So much more secure and manageable.
Exactly.
All right, let's move on to how we secure data at rest. Slide 6, secure access to storage resources.
All right.
Azure gives us several ways to control who can get at our data stored in Azure storage.
It does, and it's important to pick the right method depending on your needs.
Right.
One way to grant limited access is using shared access signatures.
SAS.
Yeah, SAS.
Okay.
It's like giving someone a temporary key to a specific room in your storage facility
Okay.
with specific instructions on what they can do. Read, write, list, and so on.
Gotcha.
And for how long,
Okay.
you have a lot of control over what a SaaS allows.
Makes sense?
This is great for when you need to give someone temporary access,
Okay.
like a third party that needs to upload a file
Oh.
or read some specific data
Right.
without giving them full access to your entire storage account.
Gotcha. So SaaS tokens provide that limited temporary access.
Exactly.
How do those compare to access keys?
Well, access keys are quite different.
Okay.
They're basically the root credentials for your whole storage account.
Right.
They give unrestricted admin-level access
Right.
to everything inside. Blobs, files, queues, tables, all of it.
Okay.
It's like having the master key to the whole storage facility.
I see.
Sometimes they're necessary
Uh-huh.
for certain admin tasks or in older systems,
Right.
but you got to be super careful with them.
Okay.
Because if someone gets hold of an access key,
Uh-huh.
they have complete control over your entire storage account.
Wow, that's risky.
Yeah. So it's generally best to use those more restricted methods like SaaS tokens whenever you can.
So SaaS tokens for specific limited access.
Right.
And treat those access keys with extreme caution. Got it. Now, the guide also talks about legal hold and retention policies.
Yeah.
What do those have to do with securing data?
They're more about data governance and compliance,
Okay.
but they play a part in security too,
Oh,
by making sure data isn't accidentally deleted
Yeah.
or, maliciously changed.
okay.
So with legal hold, you can preserve certain data
Uh-huh.
for legal reasons or investigation.
Gotcha.
It prevents that data from being deleted or modified.
So it's like putting certain documents under seal.
Exactly. Got to make sure they stay untouched.
Right.
Retention policies let you define how long you need to keep data
Okay.
to meet regulations or business needs,
Right.
and then it can be automatically deleted after that time.
Okay, so it helps manage the data life cycle
Yep,
and reduces the risk of keeping data longer than you need to.
exactly.
And you mentioned you can use tags to mark items that are subject to these policies.
Right. You can use tags to manage them within your storage account and still add new data as usual.
Okay, so these policies are important for data integrity and following the rules.
Yep.
Which are both key parts of overall data security.
For sure.
All right, let's move on to slide 7, Azure Files and Secure Transfer.
Okay.
Azure Files, being a file share service,
Yeah.
it has some unique security things to think about, right?
It does. So Azure Files, it gives you fully managed file shares in the cloud,
Right.
but it has a limitation with access control.
Okay.
RBAC, role-based access control.
Yeah.
It can only be applied at the share level,
Oh, okay.
meaning you can control who can access the whole share,
Uh-huh.
but you can't use RDAC to set detailed permissions on individual folders or files within that share.
Okay, so that's different from how it often works with on-premise file shares.
It is. It's like controlling who can enter the building.
Right.
But once they're inside, everyone has the same access to all the rooms.
Gotcha. So the permissions are broader, not at the individual file level.
Right.
So what does the guide suggest to make Azure Files more secure?
Well, given that limitation, it's crucial to turn on Secure Transfer Required
Okay.
for your Azure Files account.
Uh-huh.
This forces all communication with the file share to use HTTPS,
Okay.
which encrypts all the data being transferred.
So it's like making sure any conversation you have when accessing the file share is private.
Exactly. No eavesdropping allowed.
Okay.
So if anyone tries to connect without HTTPS, their request is blocked.
So even though you might not have super granular permissions within the share,
Right.
you can still make sure the communication itself is secure.
Exactly.
All right, onto our database services. Slide 8, database security features.
Okay.
So Azure SQL Database has some interesting security features built in.
It does. Azure SQL Database offers some really powerful ways to protect your data.
Like what?
One of the best is always encrypted.
Okay.
This goes beyond normal encryption.
Okay.
It keeps sensitive data encrypted not just when it's stored and not just when it's being transmitted,
Okay.
but even when it's being used.
Oh, wow.
So only authorized applications that have the right decryption keys can see the actual data.
So it's like having a secret code
Right.
that only certain people know to read a message.
Exactly.
Even if someone got into the database or the server's memory,
Yeah.
they'd just see gibberish without the key.
Exactly.
That's serious protection.
It is.
What about dynamic data masking? How does that help?
Dynamic data masking is great for limiting how much sensitive data non-privileged users can see.
Okay.
It lets you hide parts of the data in query results,
Uh-huh.
like showing only the last 4 digits of a credit card number
Okay.
or hiding most of an email address.
Gotcha.
The data in the database stays the same,
Right.
but what the user sees is masked.
Okay.
It's like redacting sensitive information in a document before sharing it.
That makes sense.
It helps prevent accidental data leaks.
Right. Especially to those who don't really need to see all the details.
Exactly.
There's also advanced threat protection for Azure SQL Database mentioned here. What's that all about?
Azure SQL Database Advanced Threat Protection is a security intelligence service.
Okay.
It's constantly watching your database
For what?
for any suspicious activity,
Okay.
potential threats,
Like what kind of threats?
like unusual database access patterns,
Uh-huh.
maybe a SQL injection attack,
Right.
things like that.
Gotcha.
If it spots something fishy, it sends you an alert
Okay.
and gives you advice on what to do about it.
So it's like having a security guard watching over your database 24/7,
Exactly. Always on the lookout.
ready to sound the alarm if something's not right.
Exactly.
So it helps you identify and respond to potential attacks right away.
Yep.
Okay, last but not least, slide 9, Azure Monitor,
Okay.
comprehensive monitoring solution.
Right.
So we've talked a lot about preventing security problems,
Yeah.
but what about detecting and responding to them?
That's where monitoring is critical.
And that's where Azure Monitor comes in.
Azure Monitor is a big part of any good security strategy. It's a complete monitoring and logging service.
Okay.
It gathers all sorts of data
From where?
from your Azure resources,
Okay.
applications,
Yeah.
even your on-premise infrastructure.
Wow.
Metrics, logs, you name it.
So it gives you this complete picture of your IT environment
Exactly. You need that visibility.
for security, but also just for making sure things are running smoothly.
Right.
The guide mentions 2 main types of data, metrics and logs.
Yep.
Can you explain the difference?
Sure. Metrics are numbers.
Okay.
They describe how your resources are doing at a specific moment.
Gotcha.
Things like CPU usage, network traffic, storage space.
So it's like the vital signs of your infrastructure.
Yeah, exactly.
And logs.
Logs more detailed. They're
Okay.
event-based. So you get application logs, security audit trails, system events.
Okay.
They provide a history of what's happened and often the context you need to figure out problems or investigate security incidents.
Gotcha. So if metrics are like vital signs,
Yeah,
logs are like the doctor's notes.
that's a good way to put it.
Now, Azure Monitor collects all this data.
Right.
How do you actually make sense of it all? Sounds like it could be a lot to handle.
Yeah, that's where Log Analytics comes in.
Okay.
It's a powerful service inside Azure Monitor,
Mm-hmm.
and it lets you query and analyze and visualize all those logs.
Okay.
You can use a special query language
Okay.
to search for specific events,
Yeah.
find patterns,
Uh-huh.
get real insights,
Got it.
and you can use those insights to do a lot of useful things,
Like what?
like setting up custom alerts.
Yeah.
That'll notify you if certain conditions are met.
Like if there's a potential security breach.
Exactly. You can build dashboards that give you a real-time view of your environment,
Okay.
generate reports for compliance,
Wow.
even integrate with other security systems for more in-depth analysis.
So you can be proactive and set up alerts for suspicious activity.
Right.
You can visualize your security landscape.
Yeah,
And you can even automate responses based on what you learned from Azure Monitor.
exactly.
That's powerful stuff. The guide also mentioned the Azure Diagnostic Extension and Log Analytics agents. What do those do?
Right. So those are the tools that actually collect the data
Okay.
from your Azure resources and on-premise systems
Oh.
and send it to Azure Monitor.
Got it.
So the diagnostic extension is usually used for collecting metrics and logs from Azure services,
Okay.
things like virtual machines and cloud services.
Right.
The Log Analytics agent is a small program.
Uh-huh.
You install it,